Imagine a spacecraft flying so close to the sun that it's literally inside its atmosphere, battling temperatures of over 1,000 degrees Celsius and still managing to send us stunning images of the most powerful object in our solar system. This is not science fiction. This is NASA's Parker Solar Probe. Today, we're taking you inside the closest journey ever made to our star, the incredible science behind the mission, and the mysteries it's helping to solve about the sun's invisible yet powerful solar wind. On December 24, 2023, while many of us were unwrapping Christmas gifts, NASA had its own present for the world, a new milestone in humanity's exploration of space. The Parker Solar Probe, a spacecraft the size of a small car, reached just 6.1 million kilometers or 3.8 million miles from the sun's surface. For perspective, that's 7 times closer than Mercury's orbit. From this record-breaking vantage point, it captured an extraordinary image, not of the sun's fiery surface, but of something even more elusive, the solar wind. This continuous stream of charged particles escapes the sun's grasp at astonishing speeds, often exceeding 1.6 million kilometers, or 1 million miles per hour. Now, you might be asking the obvious question: why not simply point the camera at the sun and take a close-up photo? The answer is brutally simple. It would destroy the spacecraft. Parker is equipped with a revolutionary heat shield that can withstand the blistering heat of the solar corona at over 1,000 degrees Celsius, yet keep its instruments at a comfortable 29 degrees Celsius, or 85 degrees Fahrenheit. But even with advanced filters, aiming a camera directly at the sun from this distance would let in so much light that it could overheat and damage the onboard systems. Every time the Parker Solar Probe reaches its perihelion, the closest point to the sun in its orbit, it is quite literally touching the sun's atmosphere. During these passes, its instruments measure particles, magnetic fields, and the structure of the solar wind. One of the star instruments on board is WISPR, the Wide Field Imager for Solar Probe. This camera is designed not to look at the sun directly, but to capture the faint light of particles streaming away from it. The result? Stunning, ghostly images of the solar wind escaping into space. Solar wind might sound harmless, but in reality, it's one of the most influential forces in our solar system. It shapes planetary magnetospheres, powers auroras, and, during solar storms, can disrupt satellites, power grids, and communication systems on Earth. The mystery lies in its origins. While scientists understand the basics, there's a puzzle. Some solar wind streams are incredibly fast, while others are slower and denser, moving at about 350 kilometers or 220 miles per second. What drives these differences, and how does the solar wind escape the sun's immense gravitational pull? According to Nour Rawafi, the Parker Solar Probe's project scientist at Johns Hopkins Applied Physics Laboratory, understanding this continuous flow of particles, particularly the slow solar wind, is a major challenge, especially given the diversity in these streams. But with Parker Solar Probe, we're closer than ever to uncovering their origins and evolution. Nicky Fox, NASA's Science Mission Directorate Associate Administrator, adds, "We are witnessing the birthplace of space weather threats to Earth, not just through models, but with our own eyes. This will vastly improve our ability to protect astronauts and technology here on Earth and across the solar system." Parker isn't just breaking records for proximity. It's now the fastest human-made object in history, propelled to incredible speeds by the sun's gravity. After its December achievement, the probe completed 2 more close approaches on March 22nd and June 19th, with more planned for September 15th and December 12th. The Parker Solar Probe's mission will continue for as long as its thrusters have fuel. When the time comes, the spacecraft will be rotated to expose its instruments directly to the sun's raw energy, effectively sacrificing them. The heat shield, however, will endure for millions of years, silently orbiting our star as a relic of one of humanity's boldest space missions. The Parker Solar Probe isn't just exploring the sun. It's pushing the limits of engineering, human curiosity, and our understanding of the universe. Every bit of data it sends back brings us closer to solving the mysteries of the solar wind, predicting space weather, and safeguarding our future in space. We've always looked up at the sun from Earth's surface. Now, for the first time, we're reaching out and touching it.